Hello everyone. In continuation to our topic analytical geometry, we will here discuss about how do we find the area of a triangle. In general, if A x1, y1, B x2, y2, and C x3, y3 are the vertices of a triangle ABC, then the area can be calculated as 1 by 2 times modulus of x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. Whole thing comes under modulus. Reason is area cannot take any negative value. So even if it is negative, it will be considered to be a positive value. In terms of determinant also, we can calculate. So with the same vertices x1, y1, x2, y2, x3, y3 can be evaluated as numerical value of 1 by 2 times determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. If we want to find out the area of a quadrilateral, that can be found by dividing the quadrilateral into two triangles and then add those two areas. So now we will do one simple problem. Question 13, find the area of a triangle whose vertices are 1, 6, 3, 1, 3, 0, minus 3, minus 7. So here we will consider A as 1, 6, B as 3, 0, and C as negative 3, negative 7. So this will be our x1, this is y1, this is x2, this is y2, this is x3, this is y3. So area of triangle ABC will be half times modulus of x1. So it becomes 1 multiplied by y2 minus y3. 0 minus or minus 7. So 0 plus 7 plus x2 is plus 3 times y3, which is negative 7, minus y1 minus 6 plus x3. So it is minus 3 times y1. y1 is 6 minus y2 is 0. Evaluate this. This becomes 7. This is minus 13 into 3, minus 39. This is minus 18. So this will become 1 by 2 times modulus of, this becomes minus 57, 7 minus 57, which is negative 50. Modulus of negative 50 becomes positive 50 divided by 2. So the result is 25 square units. We can evaluate the same area using determinants also. We'll see how do we do that. Here we will have x1, y1 and 1. x1 is 1, y1 is 6, 1, 6, 1. Then second coordinate is 3, 0, 1. And the third coordinate is minus 3, minus 7, 1. So this is area of triangle ABC, which is equal to half times this, which will be 1 by 2 times. We create one modulus, then 1 times 0 minus or minus 7, it becomes plus 7, minus 6. We are expanding it through the first row. Minus 6 times 3 minus or minus 3, so it is plus 3, plus 1 times minus 21, minus 0. Close the modulus. This will be half times modulus of 1 into 7, it becomes 7. This is 6 into 6 minus 36 minus 21. So that will give us 1 by 2 times 7 minus 57. Again, this is negative 50, modulus of negative 50, which is 50 by 2. So you get 25 square units. So we can either use that expanded formula or we can use the determinant to evaluate this.